Hello, people of YouTube. My name is Yusuf, and this is RxTube, a place where I talk about simple, everyday types of drugs. I'll be trying to explain at a very basic level how they work so that next time you take that pill, you can be like, oh, so that's how this thing makes me feel better. So let's start with the most well-known of all drugs, aspirin. I'm sure you must have encountered this drug. You might use it occasionally, or you know someone who does, or you might know someone who uses low doses of it regularly for their heart condition. I'll get to that soon, but first, let's talk about what it is most well known for: helping you deal with a fever, relieving general aches and pains, and getting rid of a headache. Aspirin is particularly popular for headaches, which is probably why it is used in the mornings after having a bit too much fun on a Saturday night. You know, those mornings where you're like, oh god, never again. So, aspirin can be pretty useful for helping you deal with headaches that come with hangovers or caused by this hangover. Now, remember what I said earlier. My goal is to give people a basic understanding of why they take medicines, and to do this, I will talk in simple terms how the medicine works. Ideally, I want even people with little scientific background to be a little more aware of what happens when they take that pill. With that in mind, let's get into it. Let's begin by drawing the molecular structure of aspirin. For the sake of those who are not familiar with molecular structures, I will draw every atom and bond involved. Uh, you know what? Before I do that, I'll write down the scientific name of aspirin. It's acetylsalicylic acid. Why it's called that will become clear in a minute. Okay, so the aspirin molecule contains something called a benzene ring, which I'm drawing right now. A benzene ring is just six carbon atoms attached together by single and double bonds to form a ring. See the single lines? Yeah, those show single bonds. Similarly, the double lines show double bonds. Now, every carbon has to have four bonds attached to it. For these carbons, see, there is one, the single bond, the two form the double bonds. So there is one left, and hydrogen is kind enough to help those carbons out. So each of these carbons get a hydrogen to give a total of 1, 2, 3, and 4 bonds. Now these carbons are happy. Right, so what about these two? Well, this carbon is attached to another carbon here, so it is happy with 1, 2, 3, and 4 bonds. Same here, 1, 2, 3, and 4 bonds. You get the idea. Okay, now this carbon, it is double bonded with this oxygen and single bonded with this oxygen, which itself is attached to another single bond to a hydrogen. And this whole bit together forms a group, and that group is called a carboxylic acid group. Moving over to this carbon, this single bond is with an oxygen, which itself is single bonded with another carbon. Again, the carbon needs four bonds, so we have this bond with the oxygen, then two bonds forming a double bond with another oxygen, and another single bond with another carbon. Once again, you guessed it, four bonds. And here the carbon is simply attached to 1, 2, and 3 hydrogens, together forming four bonds. And this whole bit forms another group called the acetyl group. Which brings us back to the scientific name. The acetyl part comes from, obviously, this acetyl group here. As for the salicylic acid, the acid is because of this carboxylic acid group here, and this whole bit forms salicylic acid. Now, the salicylic word itself comes from the word salix, S-A-L-I-X, salix, the Latin word for willow tree. The leaves and bark of the willow tree contains a molecule called salicylin. This molecule is converted to salicylic acid in the body. And as you would have probably guessed by now, salicylic acid relieves pain, inflammation, and so on. The properties that make aspirin famous. Salicylic acid was the reason why ancient civilizations used the bark and leaves of the willow trees as remedies for pain and fever. And by ancient, I mean ancient. How ancient? Well, without going into too much detail, and just to give you an idea, in my last video I briefly mentioned the Ebers Papyrus, the ancient Egyptian text containing information regarding hundreds of substances and their medicinal uses. Now, this document dates back to 1552 BCE, in other words, over 3,500 years. It mentions the use of willow bark for relieving pain and fever. So humans have known that there was something great about the willow tree for a long time. But it wasn't until 1838 that an Italian chemist called Raphael Pereire managed to make pure salicylic acid from salicylin extracted from willow bark. However, there was a big problem with using pure salicylic acid for pain and so on. You see, it caused stomach upset and vomiting, and because it is a fairly strong acid, irritation of the mouth and throat when you swallowed it. So, in 1853, this guy called Charles Frederick Gerhardt, he was a French chemist. I don't know if I pronounced the last name correctly or not. Gerhardt? Gerhardt, I imagine. Anyway, Charles Frederick Gerhardt, here's the name here, became the first person to turn salicylic acid into the molecule I just drew here, aka acetylsalicylic acid, aka aspirin. Gerhardt didn't want to market it, so he didn't take his discovery further. Shame, really. I imagine he could have made a lot of money, but that's just speculation on my part. Come 1899 and enter Felix Hoffmann, the man most associated with aspirin. He was working for the German company Bayer at the time, and he discovered Gerhardt's experiment, proceeded to replicate it, and succeeded in making acetylsalicylic acid. The story goes that his father suffered from rheumatoid arthritis, and he gave his father this new thing he had made. It not only helped relieve his father's pain, but also did not cause any stomach upset or irritations. Unlike Gerhardt, Hoffmann ran with the idea and convinced Bayer to market the drug. Bayer came up with the name aspirin, and it was patented on February 27, 1900.